Among the countless stories of success, this is someone who accomplished biggest heights of dreams someone could ever achieve in their lifetime. He is a proud son of Mother Rahula, a tremendously successful engineer as well as an experienced scientist in aerospace engineering industry. Having a broad knowledge into the deep ends of physics, nuclear physics and material science, who had long and extensive careers at world-renowned companies. Besides, he was the former president of the Society of Sri Lankan Engineers and Scientists and the former vice president of the Association of Professional Sri Lankans in the United Kingdom. In this journey of life, he didn't just stop by being an image of success. He wrote the book Home Away from Home, Be Happy, Be Successful in a Foreign Country, and continued his way as an author with intentions of giving practical advice and instructions to everyone finding happiness through ultimate victory. And we feel miraculously pleasured to have that exceptional personage among us in this evening at the opening of Rahal Cosmos' 21. Ladies and gentlemen, please welcome the Honorable Chief Guest of the event, Dr. Keerthi Devendra, for his valuable lecture.
Hi, good evening. Can you hear me? Can somebody tell me if you can hear me?
Yes, sir.
Okay, thank you very much indeed. Let me share my screen.
Yes, sir, you have permission.
Okay. Okay, let me start. Good evening, Shubha Sandhyava, Vanakkam. So I'm going to talk about astronomy today. But in discussing astronomy, I'm going to bring in science, engineering, and technology into the equation, because there's a big link between the astronomy and science and engineering and technology. And also I'll be using some examples from aero engines and gas turbines, because that's where I have gained a lot of experience. Let me adjust my screen. There is something. Okay. I guess I wasn't sharing my screen before. Right, okay, that's better now. I believe you can see my screen, yeah? So I'm going to talk about astronomy, but in talking about astronomy, I'm going to bring in science, engineering, and technology. And also I'm going to bring some examples from aero engines and gas turbines associated with Rolls-Royce, because that's where I got a lot of my experience. So first of all, let me congratulate Rahula A team for winning the SPHERA, is it SPHAERA 21 video creating competition. That's a great achievement. I'm very proud of you. So first of all, thank you very much for inviting me for this occasion. It's a privilege to talk to all of you. You are all very special in my mind. You are doing something most children would love to do, and you are in a very privileged position. Some children may not have the same opportunity. I think we must think of ways to create opportunities for those children as well who are in a less privileged position. Today, I am proud for many reasons. I'm so proud to see these young scientists, young engineers behaving in such a professional manner. I'm an old boy of Rahul, so I'm so proud. In addition to that, I'm proud because I'm a Sri Lankan. I'm even more proud because this audience consists of many schools representing many communities in Sri Lanka. I believe in the future, most of you will become highly educated, highly successful, happy professional adults. Although we are talking about astronomy today, some of you will become in the future teachers, doctors, engineers, lawyers, singers, artists, technologists, accountants, many different professions. This is only a pathway to develop skills. So my expectation and my hope is that you will all become world-class individuals with world-class skills, serving Sri Lanka as well as all the human beings all over the world to make their lives better. I'm going to say a few words in Sinhalese and Tamil. ඔබ ඉදිරියේ කතා කිරීමට ලැබීම ගැන මම ඉතාමත්ම සන්තෝෂයි, ඉතාමත්ම ආඩම්බරයි. මගේ අදහසේ හැටියට ඔබ හැමදෙනාම අතිවිශේෂ පුද්ගලයන්. අනාගතයේදී ඔබ හැමදෙනාම ඉතා ඉහළට ඉගෙනගෙන ඉතාම ඵලදායී වෘත්තිකයන් බවට පත්වනු ඇතයි කියලා මම බලාපොරොත්තු වෙනවා. ඔබ මොන රැකියාව කරත් මොන අංශයේ වැඩ කළත් ඔබ ඉතාමත්ම දක්ෂ ලෝකයටම සේවයක් කරන ලංකාවේ සමාජයට සේවයක් කරන අති දක්ෂ පුද්ගලයන් වේවා කියලා මම ප්‍රාර්ථනා කරනවා. உங்களை போன்று ஒரு கூட்டத்தை பேசுவாத்தி எனக்கு பெருமாய் யாவகும் மகிழ்ச்சியாகவும் இருக்கிறது. நீங்கள் எல்லோரும் எனக்கு முக்கியமானவர்கள். இனி வரும் காலங்களில் நீங்கள் கல்வி பெற்று பெரும் பெரும் பத்திரிகைகளை செய்வீர்கள் என்று நான் நம்புகிறேன். இன்று நாங்கள் astronomy பற்றி அடிக்கடி பேசினாலும் நீங்கள் டீச்சர், இன்ஜினியர், டாக்டர், சயின்டிஸ்ட், லாயராகவும் வர வேண்டும் என்று நான் எதிர்பார்க்கிறேன். So that's my little bit of Tamil. I hope you followed that, understood it. So let's get back to the main business. My presentation, I'm going to cover what is astronomy, why do we study astronomy, interesting facts about astronomy and universe, relationship between science, engineering, technology, and astronomy, and the impact on the society and living conditions. And of course, how can you achieve success and happiness as a result of all these things? Now, I believe I'm going to ask some questions from the audience, by the way, throughout my presentation. I hope the audience can answer in the chat box. Can one official confirm that that's a possibility, or is that not possible? Let me see if it's going to work. Yes, I think the chat box is okay. Chat box is. Now, I joined Rahula College at the age of 4 in the kindergarten, and I was there till GCSE O level, and having got very good results on the advice of the principal at the time and the teachers, my teachers, because at the time Rahul College was struggling to get good teachers or enough teachers for A level. My father moved me to Colombo, so I ended up in Royal College for A levels. From Royal, I joined Peradeniya University and got the first class honors degree in physics. Then I served as a lecturer in physics for a couple of years. I then came to Edinburgh in Scotland, got my MSc in nuclear physics. Then I joined the University of Sheffield and completed my PhD. in material science. In addition, I received the Berthold Eichner Memorial Prize for Research. After obtaining PhD, I worked at Leeds University as a research fellow, and then I joined Rolls-Royce. Now, Rolls-Royce is well known for cars, but their main business today is manufacturing aero engines for aircraft, ships, submarines, and trains. And I had the opportunity to work at the forefront of aerospace aero engine technology for some 34 years. And I ended up as a senior project manager. I also worked at two different companies, A-System UK and the Consumers Association in the UK. I also did some voluntary work. I was a member of the Derby City Education Committee. I was a governor of the local schools. In addition, I was a governor of the local hospital. So now let's talk about astronomy. Let us start with a short video. Now, this is something happened earlier this year in February 2021. Now, this is, of course, Mars 2020 Perseverance spacecraft landing on Moon in February 2021, a few months ago. You can see it's approaching Mars now. Now, this is an animated film created by NASA. So this is not the real thing, but it's an animated film, official film. So what I like to do is I would like to see the real live video from NASA about the Mars 2020 Perseverance landing.
Right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground. The navigation has confirmed that the parachute has deployed and we are seeing significant deceleration in the velocity. Our current velocity is 480 meters per second at an altitude of about 12 kilometers from the surface of Mars.
Heat shield set.
Perseverance is now slowed to subsonic speeds and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Nav filter converged. Velocity solution 3.3 meters per second. Altitude 7.24 kilometers.
Now has radar locked on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the timing of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
Hope you have valid.
We have confirmation that the lander vision system has produced a valid solution as part of terrain relative navigation.
Timing.
We have timing of the landing engines.
Not shelf that.
Current velocity is 83 meters per second at about 2.6.
Now 82 meters per second is about nearly 200 miles per hour.
We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
Here 50 Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity.
We can see the dust being disturbed on Mars. And also this system is using 3 cameras.
Tracking maneuver has started. About 20 meters off the surface.
Getting signals from MRO. Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life.
Now, you can see the joy and happiness in the faces of all those people involved in the whole project. So my question is, as young scientists, young engineers, young professionals, would you like to be in a team like that and celebrate success in a huge project like that? Not tomorrow, not next week, not next month. Perhaps in 5 years, 10 years, 15 years, or 20 years in time. How can you prepare yourself to be in such a situation? What can you do? What skills would you need? So let's have a quick look. Let me ask you a question, simple question. I don't know if you can answer this question. Perhaps in the chat box. Any professionals in one word, or maybe in 3 words, can anybody tell me, what do the professionals do? Engineers, scientists, teachers, doctors, any professional, what do they do commonly in 3 words, if anybody knows the answer? Okay, let me go ahead. They all solve problems. 2 words. They must be able to deliver solutions to known problems, but not simply delivering solutions. They must do it with minimum cost. I think, hang on a minute. It's going too fast. They have to solve problems with minimum cost in a timely manner, with minimum disturbance. Now, what do I mean by minimum disturbance? Now, if you are working in an organization or a team or a country, when you produce the solutions, there may be several solutions, and some people may not like some of the solutions. So you have to find a way to. Please, I need to take this control off because I need to control the screen the way I want. So, Bhuwani, I'm going to take the control off. Okay, please take it off. Please don't control the screen. I need to control my screen. I'm doing it deliberately, step by step. So in addition to being able to provide solutions, they must have the technical skills and experience. So of course, depending on whether it's an engineer or a doctor or a teacher or a scientist, the technical skills may be different. They also must have skills in planning and organizing, communications. Now, I don't mean language. Of course, the languages are important. Languages are right. I just saw the notice that you can't hear the sound. So let me stop the sharing and start again. Okay. Can you hear this now? Can somebody tell me that? Can you hear the sound now? Can you hear me now?
Yes, sir, we can hear.
Didn't you hear the beginning at all?
No, we heard it. That's no problem.
Okay, right. Okay. So when I'm talking about communication, it's more than the language. There has to be teamwork and there has to be time management. Now, if you think about it, not everybody is completely successful in any field. Only some people are 100% successful. Some people are less than that. If you are 80% successful, that would be great. If you're 75% successful, that would be excellent. I need to add some note here. Success and happiness is not the same thing. So the main point is for you have to be happy in what you are doing. As long as you are doing your best, and as long as you are happy, it is sufficiently successful for you. Now, what you notice is that the people who are extremely successful, they have clear goals, they have clear commitments. And they have the appropriate behavior to match that organization and the settings. They are hardworking, they are passionate and focused on the goals, and they never give up. And they are always prepared to learn new things and adapt to the situations. So, what additional skills do they need? They must have the skills in listening to others. They must be able to listen to others. They must be prepared to ask questions without accepting whatever the others say, unless, of course, there is validated evidence. So unless you can see the evidence, please be prepared to ask questions to get clarification. You have to identify and manage risks. In any situation, there will be risks. And you have to motivate and inspire others. And by the way, I saw plenty of evidence that the Rahula team has plenty of energy and ability to motivate and inspire. So that's great. So I'm summarizing these things again. All the professionals, regardless of their field, whether engineers, scientists, doctors, teachers, they must be able to solve problems. They must deliver the solution with minimum cost in a timely manner with minimum disturbance. They must have the technical skills and the experience for the selected profession. They must be good at planning and organizing. They must be good at communications. They must be good at teamwork. They must be good at time management. They also must be able to listen carefully to others. They must be prepared to ask good questions. They have to identify and manage risks. And they have to manage and motivate and inspire others. So what is astronomy? In simple terms, astronomy is the study of objects we see in the sky. A more precise definition is the study of everything in the universe that is beyond our planet's atmosphere. Many objects can be seen with naked eye. Our own star, the sun, the brightest star at night, and the bright stars at night, and some of the planets in our solar system can be seen with naked eye. There are many other objects we can only see with telescopes or other instruments. For example, faraway galaxies. In a similar manner, the tiny particles that make up the objects in the universe, atoms or molecules or electrons, we can only see with special instruments. In the past century or so, astronomy has been broadly split into two camps: observational astronomy, that is using telescopes and cameras to collect data, and the theoretical astronomy. And all of you are in the observational astronomy field, I believe, at a very young stage. So what is cosmology? Sometimes the term cosmology is used to mean astronomy, but strictly speaking, cosmology is the science of studying the origin and the nature of the universe. So how and why did the astronomy evolve? From the beginning of time, humans wanted to learn more and more about the world they live in. Once they understood the environment, humans wanted to control their environment. That's the normal way. It was a gradual evolution. That is how, from being hunter-gatherers, the humans gradually became farmers. Then after becoming farmers, they went through the Bronze Age, Iron Age, through industrial revolutions to get to where we are today. It is in the human nature that people always want to increase their knowledge. You are doing the same thing. As young minds, you want to learn more and more about the universe and to understand the surroundings. The human beings always had three key questions. Where are we? Where did we come from? Are we alone in the universe? Astronomy is considered to be the oldest science in human history. With naked eyes, people can always see our own star. On a clear night, we can see millions of stars in the sky. In addition, on some days, we can see the moon. Sometimes we also can see another bright object next to the moon, usually after sunset or just before sunrise. So people realize that stars in the night sky are generally stationary, gradually changing the positions in a cyclical manner every year. As a result, people started using positions of stars for navigation. For example, if you look at the sky on a clear night today at 8 o'clock in the evening, the stars will be at the same position tomorrow at the same time. So that is why they could use it for navigation. And they could use the relative position of the stars and the other planets, perhaps. So the ancient observers noted that a few of the stars in the sky were not stationary. Other millions of stars were stationary. Few stars were not stationary. So they were termed wandering stars. In fact, people realized that these are not stars, but these are objects moving around the sun. They were called planets. The term planet comes from the Greek word wanderer or planetis. Ancient people worshipped gods, often linked their gods with planets in the sky. So that is why 5 planets known since ancient times, Mercury, Venus, Mars, Jupiter, and Saturn, they are named after Roman gods. Based on observations, visual observations, ancient people concluded that the Earth was at the center of the universe, and the sun and the stars and planets were going around the Earth. So let's look at some interesting facts. Our understanding of the universe has evolved significantly over the time. In the 16th century, Polish scientist Nicholas Copernicus suggested that the Earth and other planets in the solar system are in fact going around the sun. In the late 17th century, Isaac Newton calculated how the forces between planets, specifically the gravitational forces, interacted. Our galaxy is the Milky Way, and in the early 1900s, so in the 1900s, scientists were debating if Milky Way contained the whole universe. Astronomers have estimated that there are about 100,000 million stars in Milky Way alone. That's a lot of stars. In 2016, one study estimated that the observable universe contained about 2 trillion, that is 2 million galaxies. Just think about it. Each galaxy can contain hundreds of thousands of millions of stars, and there are 2 trillion, that means 2 million galaxies. Some of those distant systems are very similar to our own Milky Way, while the others are quite different. Most scientists think that everything that we know and experience around us began at a moment known as the Big Bang, 14 billion years ago. Now, universe has evolved since then, gradually into stars and the planets and comets and so on and so forth. Does anybody know the age of the Earth? If you know, please type it into the chat box. Let me see if I get any answers. At the moment, I can't see any. So let me go ahead with the presentation. So the universe started with the Big Bang 14 billion years ago. The Milky Way is 13.6 billion years old. So the Milky Way appeared roughly after about 400 million years after the start of the universe. Earth is estimated to be about 4.54. Yes, somebody gave the correct answer. Just about, I was sharing the information here. Yes, the Earth is estimated to be about 4.54 billion years old, plus or minus 50 million years. And the scientists have been searching all over the Earth, all over the world, for evidence to decide the age of the Earth. In fact, they found in northwestern Canada, they discovered a rock which is 4.03 billion years old, because they can date these rocks using carbon dating. That's a radioisotopic technique. The moon is about 4.425 billion years old. And so the moon is about 85 million years younger than the Earth, than previously studied. So effectively, moon is, I think, a couple of hundred years younger than Earth. So this is the Milky Way. That's where we are. Now, does anybody know the brightest star on the sky? There are millions of stars in the Milky Way which we can see with the naked eye. There's one particular star which is the brightest. Sirius, yes. There are a couple of correct answers. Sirius is the brightest star. It is also called Alpha Canis Majoris, or the dog star. There is another special feature about Sirius. Does anybody know what is so special about it? Is it a single star? It's a binary star. Somebody answered it correctly. Yes, it's a binary star. So what is a binary star? A binary star or a double star or a binary system is two stars. They attract each other gravitationally and they are orbiting around themselves. They are orbiting around their common center of mass as a pair. So if the plane of their orbit lies edge on towards Earth, then each star will be seen to eclipse the other once each orbital period. And astronomers have estimated there are more than half of the stars in the Milky Way galaxy are members of double or more complex star systems. So let's look at the solar system. I'm going to ask another question. How many planets do we have in the solar system? You might think it's a very easy answer, but it's a trick answer. Yes, somebody is giving the correct answer. A lot of people are giving it's 8, but it used to be 9. So what happened to the 9th one? Now, Pluto was considered a planet in the beginning, but Pluto is no longer considered a planet. It's a dwarf planet. So we got Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. In addition to that, we have the asteroid belt between Mars and Jupiter. These asteroids, sometimes they decide to move in their own direction, and sometimes they come towards Earth. If they are small asteroids, it's okay. There is historical evidence that about several millions, 100 million years ago, a big asteroid hit Earth and destroyed what was living on Earth at the time. That is how we lost dinosaurs. As you may know, USA and perhaps other countries are now investigating how can we detect asteroids, large asteroids coming towards Earth. If they are going to hit Earth, what can we do to avoid them? For example, you could send an aircraft or a rocket and a bomb and deliberately hit the asteroid so that we can move the asteroid away from the Earth. So it's the safety of the Earth. Now, as you can see, towards the outer edges, we got the Kuiper belt. So asteroid belt, we got asteroids. These are real hard materials. In the Kuiper belt is all actually frozen ice, large lumps of frozen ice. Now, a lot of people are interested in Mars. We have already seen a couple of videos, about landing on Mars. Why Mars? Why is that astronomers are in many countries, several countries, astronomers are very keen to study Mars? That is because the life probably existed in Mars in the past. So they are looking for evidence. They want to understand the surface of the Mars and its evolution. And the astronomers already believe there is some signs of water vapor in the Mars atmosphere, very small amount. It is possible that at a later date, there may be human explorations onto Mars. So understanding whether the life existed elsewhere in the universe beyond Earth is a fundamental question the humans ask already. So they are looking into Mars to provide that evidence. So and also, of course, there is other additional information. So let's look at some interesting facts about Mars. On Mars, the sun appears to be half the size as we see from Earth because sun is further away. The temperature on Mars is on average, is about minus 81 degrees Fahrenheit. That's extremely cold. But the temperature on Mars varies, minus 220 degrees Fahrenheit, and the highest about 70 degrees Fahrenheit, which is about 20 Celsius on certain days at certain points. Mars is about half the size of Earth's diameter. The atmosphere on Mars is much thinner, so the average surface pressure is only about 610 pascals, which is 0.088 psi, which is less than 1% of the Earth's value. The gravity on Mars is 3.721, which is about 1/3 of the gravity on Earth. Mars has very large dust storms in the solar system. They are the largest. Mars also has the tallest mountain in the solar system as far as we know. The tallest mountain on Mars is named Olympus Mons, which is Mount Olympus, and it's about 13.6 miles tall. Now think about the highest mountain on Earth, which is Mount Everest. That's about just over 5 miles tall. This is about 13 miles tall. So that's enormous. So the very first time any spacecraft flew near Mars was in 1965. I was a young boy at the time. I was at Rahul at the time, by the way. I left Rahul in 1965. The spacecraft Mariner flew by Mars at a distance of about 600 miles. And that was the first time anybody ever managed to take any close-up pictures of any other planet. So that was a huge milestone. To celebrate the 30th anniversary of that event, NASA sent a spacecraft called Sojourner, which means the traveler or rover, in 1996. It landed on Mars on the 4th of July, 1997. It was supposed to last 7 days, but it did last 83 days. That was quite an important event. In addition to that, in 2004, 2 other spacecrafts were sent. MER-A, that is Mars Exploration Rover A. Now that unfortunately didn't last very long, that it had some problem. But the Mars Exploration Rover B lasted 15 years until 2018. It was supposed to last only 3 months. So that was a remarkable achievement. Now, what happened to that Mars Rover B, which was sent in 2004? It depended on solar panels for electricity. So there was a big dust storm, it seems, and it covered the solar panels for a long time. So if the solar panels are covered, the vehicle runs out of electricity, and that's what happened. So since then, NASA has found other ways to manage the power supplies. In 2012, Curiosity rover, it is a car-sized large rover, landed on Mars on the 6th of August 2012. And that is still operational. Right. Mars 2020 Perseverance. It started the mission in July last year. It landed on Mars in February this year. The power supply on that vehicle is not solar power. It is nuclear powered, MMRTG. It is supposed to last 14 years. It is providing safety and optimizing the power, and a minimum lifetime of 14 years. So hopefully we'll keep getting information for a long time to come. Now, I'd like to take you back and look at another video, because these videos gives a realistic view of what's happening. So it was sent from Cape Canaveral in USA. So after that, of course, in 2004, 2012, and 2020, the aircraft sent by NASA. So let's understand the impact of astronomy on sciences, technology, and engineering, and maths, and the society. Sometimes we take things for granted. So in 1543, Nicholas Copernicus, he produced a radical theory saying that the planets are rotating around the sun, not around Earth. But he couldn't prove it. Galileo Galilei, who produced the telescope, who is considered as the father of modern astronomy and physics, was the first person to look at Venus through a telescope. And through his work, he proved that Copernicus was right. And that Earth and all the other planets were rotating around the sun. Since that time, more and more people have studied stars and the universe with more and more advanced technologies. We now have extremely powerful instruments to look at the sky. We have huge radio telescopes. We have huge arrays of radio telescopes so that we can look at billions of light years away galaxies and black holes and stars and whatever. Just as the optical telescopes collect visible light, radio telescopes collect weak radio waves and bring it to focus, amplify it, and make it available for analysis. We use radio telescopes to study naturally occurring weak signals from stars, galaxies, black holes, and other astronomical objects. These specially designed radio telescopes observe the longest wavelength of light, ranging from 1 millimeter to about 10 meters long. For comparison, if you think about the light waves are only a few hundred of nanometers long. For example, blue light has a wavelength of about frequency of about 4.3 times 10 to the power 14, whereas radio waves have a frequency range of about 300 gigahertz to 30 megahertz. Now, this is one of the largest radio telescopes on Earth. It's built in China. It's about to be commissioned, or it was commissioned recently in China. So we should be able to see even more details of the universe with this telescope. It's tremendous technology. To get this to operate, they had to use all the sciences, all the understanding, all the remote control systems, computer science, artificial intelligence, robotics, everything had to go into this to get it to work. So it's a tremendous achievement for the humankind. Let me talk a little about our systematic scientific methodology. So astronomers were very keen to understand what they saw in the sky. I think you are at the beginning of your presentation, you gave some of this information before you started the ceremony today. So they observed what they saw. They measured, collected, and recorded data. They analyzed the data and came up with hypotheses or theories. And then they made predictions using those theories. To check those predictions, to check those hypotheses, they observed and collected more data. Sometimes the collected data didn't agree with the theory. So like Copernicus and Galileo saying, Earth was not at the center of the universe, it was the sun, and the planets were rotating around the sun. So when we collect data and analyze the data, sometimes we have to go back to the beginning again. It's a cyclic process. Observe, analyze, collect data, analyze, theorize, hypothesize, and go back to the beginning again. So this is the scientific methodology. This is what we use in every other scientific field now, but it started with astronomy. I'm going to ask another question, by the way. You may have already seen the answer somewhere. What's the earliest science of human astrology? How old was the astrology as a science? Where was it? Can anybody answer in the chat box? How old is astronomy? Where was it? Who studied astronomy? Yes, I got an answer. Babylonians. It is about. It is reasonably correct, but I'm not too sure if it is 100% correct. But it's a very good attempt. Thank you very much for that answer. let me, because what happened was, it was in Mesopotamia, about 5,000 years ago, they first studied astronomy. But since then, after that, Babylonians came along, and after that, Greek and Romans studied astronomy. So there's a long history. And the studies of this astronomy has led to the lot of other technologies we use today, like the GPS system, satellites, helping military and law enforcement, protecting the planet. Smartphones, you may not know, smartphones is possible only because the attempts to understand astronomy in a roundabout way. And of course, as you are being enthusiastic in this, astronomy has led to the youth to understand and study science, which is a great thing. Not only that, astronomy brings in various nations in the world together, although they have opposing political systems, which is a good thing. Western countries are working together with countries like Russia and China when it comes to astronomy. So this is great. So let's look at the influence of the astronomy. As we understood already, astronomy is about 5,000 years old. It started in Mesopotamia and then in Babylon. And because of astronomy, people had to find a way to record these things, analyze these things. That's how the mathematics arrived. So there is evidence that about 3,000 years before Christ, Sumerians were using some kind of arithmetic or mathematics. And 500 BC, of course, we had Pythagoras and other Greek astronomers or mathematicians. And as a result of mathematics, we developed into physics, which is going back about 400 BC. And as a result of physics and mathematics, in the 17th century, only about 400 years ago, people started to understand chemistry and the biological sciences. Now, as a result, we got all kinds of engineered products, civil engineering, mechanical engineering, electrical, electronic, medicine, food production. Of course, medical system existed for thousands of years before that, but those ancient medical systems were based on trial and error and experience, not scientific understanding. So that's the difference. So now, of course, we got chemicals, computing, and everything else. So you can see that astronomy has led to the development of STEM, science, technology, engineering, and maths. But now we are using the STEM understanding and knowledge and the technology developed because of that to further investigate, further understand the astronomy and the space today. So what are the tools we use today for astronomy? We use electronic communications, rockets, robots, and control systems, satellites, and high-powered computers. Now, you may not have realized, for space exploration, we have to use the right communication system, right materials. If you don't use the right materials, what happens? These robots or these spacecraft wouldn't survive. So we have to understand the manufacturing system, control systems. So all these sciences have evolved because and around astronomy, around understanding the universe, and they have all helped to enhance our life. It has made our life more comfortable. We got roads and trains and cars and clothes and whatever, lots of things. latest technologies based on these sciences. Now, my experience is mostly with aircraft and air engines. You may ask, so what is the connection? What is the connection between space exploration, rockets, and civil aviation, or aviation, including aircrafts and air engines? Let me compare the two things. On one side, on the left-hand side, I got this space exploration and using rockets. On the right-hand side, I got the aviation based on aircraft and air engines. For space exploration, we have to be able to solve very complex problems. For air engines, we have to use very complex problems. Not the same, but similar. For space exploration, we have to use science, maths, computing. For air engines and aircraft, we have to use science, maths, and computing. For space exploration, we have to use engineering design, specifically for those activities. For air engines and aircraft, we have to use special design for those applications. We have to use technology and electronics, and the same there. We have to understand the impact of environment and the interaction with the environment when sending spacecrafts and rockets. We have the same problem in air engines and aircraft. But of course, it's a different environment, but the principles are the same. As we discussed, on Earth, we got our atmosphere based on oxygen and nitrogen mostly. On Mars, we got carbon dioxide based environment, not oxygen or nitrogen. So we have to use the right materials for these things, for the space exploration. And we have to use the right materials for air engines and aircrafts. I can go into a lot of details, but unfortunately, we don't have the time. We have to generate power and control for space explorations. We have to generate power and control on aircraft and air engines. I'm going to stop for a second here. I'm going to ask a question. Can anybody tell me what type of fuel do we use for rockets in going into the space? Any short answers? What type of fuel is used for rockets? I'm just waiting to see if there are any answers in the chat box. It says hydrogen, liquid and solid fuels. Okay, solid and liquid. They are half right. They're not fully wrong. They are, yes, we do use liquid hydrogen for some certain things, but it's mostly solid fuel. But we cannot use the fuel we use for aircrafts and for rockets. Why is that? Can anybody tell me? Cryogenic? Okay, yes, that's a good answer. But why can't we use liquid fuels? Why can't we use the petroleum or gasoline or anything like that? Any quick answers? Can anybody think of the reasons? When we use liquid fuel, what do we burn? What do we use to burn them? Now, for aircrafts or air engines, when you are burning kerosene or petrol, what is the most important ingredient to burn them? It's a simple answer. It's a trick question, by the way. Oxygen. Yes, somebody said oxidizer. Yes. In our atmosphere, we got plenty of oxygen. But once we leave our atmosphere, there is no oxygen. So unless you carry with you oxidizers and liquid oxygen or solid oxygen, solidified, there is no oxygen. So that is the problem. That's a different design philosophy. So coming back to where we are, I'm comparing space exploration with aero engines. So one of the key things is for aircrafts and aero engines, we can use our atmosphere, which we got plenty of oxygen in our atmosphere, so we can burn kerosene. We can carbon-based liquid fuel, but we can't do it on the rockets. We need control systems. As we have seen in the videos, lots of things are controlled remotely from Earth. So we need electronic control system. And that's the same on air engines. The pilot flying the aircraft, he has to control the aero engine sitting in his pilot's seat. And also he has to understand what's happening on ground though, around the aircraft. And we need to control it, everything depending on the environment. We have to ensure safety of the rockets and space explorations. Why? Why is safety so important for a rocket? Can anybody tell me why? In the chat box. Again, I'm asking a difficult question. It's not obvious, but there's a good reason. Now, if we fire a rocket to send to Mars today, if it fails and if it is destroyed, what's the impact? To get the next rocket, it might take 4 years because you have to time it in such a way that the planetary system is in the right place at the right way. And not only that, the cost of failure could be several $1 billion. So safety is important and essential for space exploration. But for air engines and aircraft, also safety is essential and important. Why is it important for aircrafts? Any answers in the chat box? For an aircraft, why is the safety important? It is important because in each aircraft, we are carrying about, I don't know, sometimes 100, sometimes 200. In a large aircraft, about 550 people. If an engine fails or the aircraft fails, that's about 550 lives. So human life is very important. So therefore, we have to ensure that everything on an engine or an aircraft is absolutely safe. Yes, that's right. Somebody answered, ensure the safety of the cargo and the crew. Yes, the cargo in case could be people. If it's a cargo aircraft, yes, that's right. So safety of people is essential. So how do we ensure safety? For the space exploration and rockets, we test the system before we send them to the space. What do we do with air engines and aircrafts? We do testing on ground or in the labs. It's the same, similar but different, but at the same time, it's the same principle. We have to have remote data collection for space exploration. Although it's not obvious, although you may not know it, for aero engines and aircraft also there is remote data collection. I live near Rolls-Royce in Derby. In Rolls-Royce, there's a special building. Their job is to collect remote data from all the engines flying in air at the moment, at any moment. So they get the information about the engines and the aircraft sitting about thousands or several thousand miles away. It's the same system or similar system. And we use robotics, both aero engines, for different purposes. So what I have demonstrated is that the technology and the science and the behaviors and the principles for space exploration and aero engines are almost the same. I can give so many other examples. And teamwork and communication, absolutely essential. Aero engines and aircraft, teamwork and communication, absolutely essential. By the way, how am I doing for time? I wasn't keeping an eye. I hope I'm okay. So let's look at the safety and reliability. This is very important for young scientists and young engineers to understand. This is a summary of the things we do to ensure safety and reliability of the aircraft. The similar things are done for rockets and the spacecrafts. We look at the failure probability of components and systems. We identify which parts are critical. We understand their behavior. We do component and system modeling, computer modeling. We understand the stress analysis. We do what's called the computational fluid dynamics so that we can understand the behavior of air. I will show you it in a minute. In an engine, We model oil systems and fuel systems. In addition, we look at every component separately. At the same time, we look at systems separately. We test them separately. We verify the control system in labs. We check and verify the engine control systems, functionality in huge labs. After doing all these things, after building engines, we test the engines on ground. We also test the engines, aircrafts on ground. After testing on ground, we do flight testing. Now, of course, the flight tests are carried out by specialist pilots who are trained to handle danger. We'll look at something if we have the time. So these are the techniques we use to ensure reliability and safety. So I'm going to go through quickly. Now, this is a picture of a test we did for RB211 some years ago. We deliberately failed the shaft in the engine. That's the outcome. Can you see the damage? Now, if that happens on an aircraft, lives of hundreds of people could be in danger. I said correct materials. Now, I am showing the picture of 3 turbine blades. They are all cast metals. I'm going to ask a difficult question. You may not know the answer. Can anybody see the difference between them? If you know the difference, put it in the chat box. You can see the appearance is different, but what is the difference? In this blade, it's a traditionally cast blade. There are millions of grains in that blade, millions of grains in all kinds of directions. So the properties are not that good. In this blade in the middle, there are only, not millions, only about 100 grains. They are all aligned along the axis. So this is much stronger. And this blade on the right-hand side, which looks dark, it's a single grain or single crystal, should I say. This one has millions of crystals. This has about few hundred crystals, aligned, large, long crystals. This has a single crystal, millions and billions of atoms, but they are all structured in one cell, one crystal. The manufacturing these things takes special effort. They are very expensive. This blade here, each blade can cost 1,500 pounds. That's about, I can't remember in rupees, that's a lot of money. So let's look at the next one. That's the turbine blade. Again, this operates in the turbine in the engine, aero engines. I said that it is very important to understand the materials and design the materials and manufacture materials. Does anybody know what is the melting temperature of a metal? Roughly, approximately, not exactly. So can somebody type in, if you know the answer, what's the melting temperature of iron, for example, roughly? I can't see any answers, but I will give the answer. Metals melt. Oh yes, somebody gets 1,000 degrees. Okay, it's 1,000 Celsius. It's not bad. Some metals melt at 1,000 Celsius, but the aerospace alloys melt at about, 10,000 is too high. They melt before 1,400. That's 1,400 Celsius. So all the metals that we know can melt at 1,400 or under. So this blade can melt at 1,400. So let's watch the rest of the slide. There is some interesting fact. Now this blade can generate the power. Each blade can generate the power of one Formula One car. That's a lot of power. And the tip of the blade, this tip rotates at the speed of about, because at the center it's rotating slowly. The speed at the middle is slow because they are rotating. And that tip travels at around 1,000 miles per hour. and it operates at a temperature of 1800 Kelvin, which is about 1500 Celsius. Now, I told you already, it melts at 1400. So how does it operate? How does it remain as intact? Now, it's a lot of technology. If you can see these are little cooling holes. There's cooling air flown through this to keep it cool. So although the air around is at 1800 Kelvin, the blade itself is at about maybe 700-800 Kelvin because of the cooling air. Now that's a huge amount of technology. So like that, we have to use special techniques, special designs, special technology to manufacture these things. It's the same for rockets. It's the same for spacecrafts. Now let's look at computer modeling we use. Now this is inside the turbine blade. Inside the turbine, I mean. That's the turbine blade. This is the turbine blade. What we call these things stators. They don't rotate. Only the turbine blades rotate. So let's look at it. Now this red dot is the air going through. So you can see that in this model, this sort of blade, this row of blades rotates in the opposite direction to the other row of blades. Let me see it again. Okay. So also we can, so using this computer model, we can understand what happens to the air, what happens to the blades and vanes. So that's one particular design. The blades are rotating in opposite directions. And the next one, in this one, you can see that the blades are rotating in the same direction. So that's a different design. So that's an illustration of how we use computer modeling to understand the behaviors. So let's look at another video. This is about engine testing. This is about 10900 engine for A380 aircraft. A380 is the largest aircraft on Earth. It can carry up to, normally it can carry up to 550 passengers. It's a huge aircraft. It's still operational. So let's look at this.
They would buy engines built by Rolls-Royce, capable of providing 30% more thrust than the engines used on the 747. Each massive power plant cost $15 million, as much as a ton of gold. Altogether, they account for almost 25% of the cost of the entire plane. But if there's one thing this aircraft needs, it's thrust that won't quit. Each engine provides up to 80,000 pounds of force. Running at top speed, this mega guzzler sucks down a litre of gasoline every second. The A380 is designed for routine flights lasting 13 hours or more. That means when it's fully tanked for takeoff, the A380 carries a lot of fuel. 260,000 litres, 20% more than the load carried by the 747. Just imagine what would happen if anything threatened the integrity of one of those fuel tanks, like a catastrophic engine failure that sends shards of metal tearing through them. That's the nightmare that haunts engineers at Rolls-Royce, and they're about to destroy an engine to make sure it never occurs. These 24 titanium fan blades suck air into the maw of this A380 engine. Each blade is 1 meter in length and weighs 15 kilograms. Lightweight, but super strong. When the engine is roaring along at full throttle, the blades spin at almost 3,000 revolutions per minute. The centrifugal force at the tip of each blade is equivalent to the weight of a 110-ton locomotive. If one of these were to break off and escape into the engine, it could wreak unimaginable destruction to the plane. That's why Rolls-Royce engineers are about to conduct an engine failure test. They're going to intentionally cause one of the fan blades to break off at full speed in order to prove that the engine enclosure can contain the damage without letting any metallic fragments escape. In the process, they will totally trash this $15 million engineering marvel, a small price to pay when the lives of over 550 people could be at stake. A super slow-motion camera captures every moment in excruciating detail. The blades are striped to make visual measurement easier. When the fan is spinning at full speed, engineers send a signal to explosive bolts at the base of the multicolored test blade. Faster than even this camera can see, the knife-like piece of metal shears off and flies into the engine mechanism, wreaking havoc, but no fragments escape. The A380 engines are safe for flight, but there are many more pieces to the puzzle.
Okay, now that's an example of a real engine test. So we do lots of engine tests like that. In fact, to design and develop a new engine for a new aircraft can take up to 5 years and could cost about £1 billion. That's about 300 billion rupees. And it can take 3 or 4, 5 years. And it involves about 3,000 engineers and scientists. Now, as I said, to ensure the safety of an aircraft or an engine, to make sure that everything works properly, we do a lot of testing, a lot of modeling. It's the same for spacecrafts and rockets and expeditions. So the next thing I'm going to share is a very recent video from NASA demonstrating something they did recently. Of course, NASA has this Mars 2020 Perseverance is already on Mars. It is looking at materials, but they want to send something to Mars without humans to bring back some samples from Mars, because sending humans to Mars is not possible at the moment. So what they're doing is they're testing concepts and materials and new systems to make it happen. So let's look at this video.
3, 2, 1, fire.
If there's a question that we don't know the answer to, we will test it.
Sequencer on 5, 4,
3, 2,
1.
Now that the Perseverance rover has started to collect the first samples, that has kicked off the Mars Sample Return mission.
The goal of Mars Sample Return is to pick up those samples from Mars and bring them back to Earth.
This mission has many crucial components involving many NASA centers as well as international partners. The tests we're running right now are just the first step in making this mission possible.
What this testbed is working to achieve is early prototype drop tests for the sample retrieval lander that's going to go pick up the rock samples on Mars. 3, 2, 1.
After we've landed on Mars, the samples have been transferred into the Mars Ascent System.
We take the rocket and we actually throw it up in the air before we light it off.
It's an ambitious effort because we've never done this before.
Sequencer armed. 3, 2, 1, fire.
This test that we just did goes a long way to showing that it's possible.
That this is the correct path to go down to have a successful launch on Mars.
Once the samples have left the surface of Mars, they will be captured by the Earth Return Orbiter, where they will be safely contained so they can be brought back to Earth.
This particular tower is designed to test out one of the last elements of Mars Sample Return, its impact landing on Earth.
3, 2, 1.
We get to demonstrate how strong these hardware elements are to prove that these samples can be brought back safely, that we design a system that can stay contained and keep these Mars materials separate from the Earth's biosphere. We're still in the development phase right now, and so we're still using these tests as a learning mechanism.
We need to know the information to make sure that we can make a mission on another planet work.
In order to accomplish goals such as bringing samples back from Mars, you have to sometimes dare mighty things.
So that's a test they are carrying out. It is not fully developed yet, but they want to develop it and send it to Mars and bring back samples. So that's the kind of thing they have to do. These things takes a lot of effort and a lot of time and a lot of brain power. And I believe there is plenty of brain power in Sri Lanka. We have to organize those brain power in a systematic way to produce the right results. And I sincerely hope. Now, although there are a lot of other things I could talk about, I want to end this presentation now, although I can present a few other things. I want to acknowledge some of the contributions. So in preparing this presentation, I have used information from many different sources. I'm very grateful and acknowledge and thank these organizations, in particular NASA and Rolls-Royce and several other websites. So now that's Concorde aircraft, Rolls-Royce engines. So thank you very much indeed. Now I believe we have a few minutes or some minutes for any questions and answers. There is something else I can share if you need, but let's go to questions and answers. So are there any questions? I suppose people can raise the hand and ask questions, or they can put it in the chat box. So there are two possibilities. Any questions at all? So if there are any questions, of course, if they can't answer the question today, they can contact the organizers. They can send me the questions by email or something. I can try to provide answers. And also, can I share, if you don't have any questions at the moment, can I share another video which might be of interest? Who is the host? Who is the person managing the discussions? So is it okay for me to share the screen and share another video?
Yeah, sir. Yes, sir.
Okay, let me share this one. Because this is interesting, just to show so I said about testing aircrafts and sometimes anything else. These are essentially tests to get the reliability. Normally, the aircraft will be flying like this, but in an emergency, we need to be able to do this. Okay, now let's have another quick look at this one very shortly. This is a vertical takeoff and landing aircraft. Rolls-Royce developed the engines and the technology for this. It's quite an old aircraft. This can take off without a runway. So let me go back and show something else very quickly. Now this, you may have seen it before. This is the first flight by Wright brothers. Now look at this video. This is how the aircraft technology starts about nearly 120 years ago. Now, would you like to fly on an aircraft like this today? But this is how it started. So don't worry about the start. The important thing is to keep working in the right direction and pay attention and do the right thing with full enthusiasm as we are doing today. Now, for their first flight, the aircraft couldn't take off on its own, so they had to lift the aircraft first using a kind of a pulley system. Can you see the pulley system working? Yes, the aircraft is lifted, it's moving. And the flight lasted only about 10 seconds, by the way. But that was a remarkable achievement, especially when the scientists and the big people at the time said that it is not going to happen. It will never be able to fly. So against that backdrop, where all the scientists and engineers were saying it is impossible to fly an aircraft, Wright brothers proved everybody wrong. So that is 120 years ago. From where they started, today we got aircraft which can fly for 14, 15 hours, not 10 seconds, carrying about 500 people and tons of cargo safely, about 6,000 miles. So now my last one, I will share it as well. It's very interesting. If I can find it quickly. Give me a second. I think Can you see the screen, by the way? Can somebody tell me?
Yes, sir.
Can you see an aircraft, something like an aircraft, vertically, but 3 people in the foreground?
Yes, sir.
Okay. So this is the last video I'm going to share. So starting from the first flight 120 years ago, that's a very modern aircraft. It's actually a Russian aircraft, military aircraft. So I think there are a couple of questions in the background. Let me see. So somebody has asked, how will be the future technologies in the aircraft industry? Can people have flying cars in the future in day-to-day life? That's a very good, very interesting question. Yes, I have an answer. They are not necessarily flying cars, but there will be very small aircraft which can take off, like the one I showed you, which can take off without a long runway. Bit more like helicopters, but like that Pegasus aircraft which took off from a ship. They can take off from a certain place vertically, then flying 100 miles or 200 miles to the next destination. Of course, you wouldn't use a flying car, flying aeroplane to travel 2 miles. You will use it for 100 miles or 200 miles or 50 miles or whatever. So that's possible. So Rolls-Royce is developing already its technology for renewable energy based. You can also solar power based aircraft. They are at a very early stage. They are very small aircraft. The intention is that they can, about 4 or 5 people can travel in them. They can travel 200-300 miles at a time, going from one town to another. So that could be realistic, possibly in the next 5 to 10 years, or even earlier. So the technology is being developed. They are not based on liquid fuel. They are based on rechargeable batteries and solar power. Does that answer the question? Right, that's another question. I just saw it now. Could I let you know how to become an astrobiology scientist? Now, that's a very highly specialized area. So you would need the understanding of biology as well as understanding of astrology and engineering to some extent. In fact, I met the first woman who went to space from United Kingdom, because I took part in a meeting a couple of years ago. She is from Sheffield University. Now, she studied chemistry at first, not engineering, not biology. She studied chemistry. But because she was so committed and she was so enthusiastic, she managed to get into the space program. And she went to space. She spent 6 months in the space station doing experiments on chemistry and biology. So my suggestion is that do whatever you do well with 100% commitment. 100% enthusiasm. Study whatever you study well. And of course, your first degree doesn't mean that that's what you're going to do forever. That's only the start. For example, I started with physics, but eventually I became a specialist in material science, and of course, I became a specialist in engine design and management and testing. So as long as you keep learning all the time, as long as you are enthusiastic, as long as you are prepared to work hard and remain enthusiastic, you can achieve your goal. So you may start with biology, you may start with physics, you can start with astronomy, you can start with engineering. With any of these fields, if you keep working, you can get there, but it might take 5, 10, 15 years. And of course, when you show enthusiasm, sometimes the doors open, as it did for me. So does that answer that question? I suppose I did, yeah? Any other questions? How to become a space doctor in NASA? So of course, that's a very challenging situation as well. I think first of all, you have to become a medical doctor in that case. If I mean you mean a medical doctor, or if you are a PhD, it's much a lot easier. So if you want to join NASA and being a medical doctor, the first step is to become a medical doctor, and then maybe you do some MSc course in space science or space engineering, and keep applying for such vacancies. Because there is so much competition, it's not going to be easy, but as long as you keep focused and as long as you keep trying, the doors will open, you will get there. There is a question here. How can I become an observer? I don't quite understand that question. Does it mean, I think it's Tanuja asking, but I don't understand question. Okay. So perhaps the fact that I don't understand the question about that, how do I become an observer? Oh, I see. Now I understand. The question is, how can I work in an observatory? That's much better. So asking the question in the correct way is also an art. It's a science. So if somebody doesn't understand your question, you must learn to rephrase it in a way that person understands. Like in this case, now I understand the question. So observatories are, of course, they employ all kinds of different scientists. They employ physicists, they employ engineers, they employ mathematicians. So again, you can start with a degree in any of those fields, maths, science, engineering, and maybe then you aim to do an MSc in astronomy or something. So that would lay the background, with the right background for you to apply for jobs in observatories. There are plenty of observatories throughout the world. There used to be one in Sri Lanka as well. So, so yes, to work in an observatory, does that make sense? Start with any degree you like, then do an MSc in astronomy at a recognized university, and then apply for jobs in those places. Of course, as long as you are dedicated and you are prepared to work hard, show enthusiasm, somebody will open the door for you. So there's another question. Can you explain whether citizenship affects being an astronaut? Yes and no. The citizenship is a sensitive issue. Having said that, there are ways to get around that if you are prepared to put a lot of hard work to become an astronaut. I guess you know that apart from having the right technical knowledge, you have to spend about 6-7 years training. So you have to be physically very strong as well. Unless you are going to space for only about 10 minutes like recently did and they pay $1 million. So become a real astronaut who spends weeks and months and sometimes years in space. You have to be physically very strong. You have to go through a lot of endurance, a lot of training. And to get into the queue is a very, only about from each country, like UK, there is a pool of about 20 people, I think. In USA, there may be a pool of 30-40 people. Same in other countries, Germany or whatever. So you need to become an astronaut at the moment, you have to end up in a country like that. Then you have to work the right organization. You have to be physically fit. You have to be prepared to go through the 6-7 years of training. And that may become possible. I would never say never. Anything is possible if you put the mind to it. I hope that answers your question. So somebody is asking for my email address. In fact, I'll put my email address in the chat box. Please so that is one of my email addresses. So obviously, if you send me an email, I might sometimes take a little bit of time to answer, but I would generally tend to answer emails, and I'll try to my best to be helpful. And there is always possibilities to find a way to achieve what you want to achieve. And you have, by taking part in this session, you have shown your enthusiasm already. You have shown that you are committed. You have shown that you have the energy. You have the passion. So you have already taken the first step in the right direction. So I believe everybody in this audience, I can see about 80 people, 84 people. I think all of you are so special, so capable. I believe you all can go a long way. My only suggestion is, please focus on serving the society, serving Sri Lanka, serving the world, serving people. Always focus on helping other people. This is a genuine advice. Sometimes the things don't work as you expect. It happened to me as well. But when things went wrong, I decided about 10 years ago, at a certain situation, I said to myself, okay, things are not happening the way I like, but I'm going to do 100% of my best to get the results for the benefit of the organization and help other people around me. And 3 years later, everybody started saying, Keerthi, you have done so well. You have proved yourself. And things started working in my favor. So your focus must be, yes, do something you are interested in, but use it as a vehicle to help others, help around you, your friends, colleagues, teammates, your organization, your company, your country, the whole world, whole human nature. So take every opportunity to use your skills to help others. So doors will automatically open so that you can achieve whatever you want. Does that make sense? I hope it is clear. So we had a long session, and Thank you very much indeed. Send me any questions by email if you have. Who is the host, the chair at the moment? Does this bring us to the end of the session, the end of the this particular part of the agenda?
Yes, sir. We are coming to the end of this session, and we are ready to the next part.
Okay. So thank you very much indeed. I really enjoyed talking to you, and hope you also learned something new. And I'll do whatever I can do to help from a distance. Okay. Thank you very much indeed. Thank you.